So let's try a problem on dimensional analysis. A contractor needs to purchase 250 bricks. The dimensions of each brick are 5.1 centimeters, 0.102 meters, obviously we have different units here, so we're going to have to convert, 5.203 meters. And the density of each brick is 1,920,000 grams per cubic meter. Now, because right here it gives you the density per cubic meter, that means we want everything to be in meters. The cost of a brick is 30 cents per kilogram. How much will it cost for the 250 bricks? Round to the nearest dollar. So the first step is to make a conversion. Okay, we want cubic meters, which means that the 5.1 centimeters has to change to meters. So we write down King Hot Dog drank cold milk. We're on centimeters, which is the C. Meters is the line right here. It's right in the middle. It's the unit. If anyone thought it was this M, that M is millimeters. Okay, so centimeters to meters, I move the decimal 2 to the left, which would make it 0.051 meters. Next step is to actually find the volume of the brick, one brick, because it gives you the density per cubic meter here, grams per cubic meter, which is the volume. So volume, it's a brick. A brick is a rectangular prism. The volume is length times width times height. So we're going to multiply each of the dimensions that it gave us for the brick, 0.051 times 0.102 times 0.203. Now, when you put this into the calculator, make sure you don't round because we're not even close to being done with this problem. So let me type this in here. And I get, okay, you get a number where I think you would maybe think that you're wrong, but it comes out to be 0.00105. 6006. Now remember, this is cubic meters. Next thing I like to do before I use the density and talk about the money is that he's purchasing 250 bricks. And sometimes if I wait till the end of the problem to deal with that, I honestly forget about it. So I like to do it right now. That's the volume of one brick. So take that number and multiply it by 250. It comes from the first sentence here. Okay, so if you multiply it by 250, this will be the volume of 250 bricks. And again, you don't want to round, so we get 0.2640015. This is cubic meters. Now, although this problem talks about density, it then discusses the cost, right? We want to get the cost of the 250 bricks. So I actually don't use the density formula. You totally could. You could use the density formula, then you can deal with the money. I don't do it that way. I like to do it setting it up as dimensional analysis where the units cancel out. So if you would like to try it the other way using the density formula, that's totally fine. Just make sure you get the same answer as me at the end. Okay, so what you do is this. You take your volume and that you just found, and you're just going to put that on the top of the fraction here. And you want to label. If you don't label, this is going to be extremely confusing because you won't know if you're placing things in the right spot. So that's cubic meters, and you just always put it over 1. Okay, top and bottom of the fractions need to cancel. So if I have cubic meters here, I need cubic meters on the bottom. So you go back to the problem, and the cubic meters comes up with this number here. Now, it's 1,920,000 grams. So we're going to label that with a G for grams. Per, the line there means per, that's your division right here, per cubic meter. If it's per cubic meter, it's talking about for 1 cubic meter. Okay, so I don't want to cancel yet because we're not done setting it up, but see how if I did cancel top, bottom, meters cubed would cancel out. Okay, next fraction. I have grams on top. I need grams to be in the bottom because I need to cancel those out. And then the money would be what's left, and that's what we want. We want to figure out the cost. Well, right now, if I just took what it gave us and put it in the fraction, I wouldn't have it set up correctly because it says 30 cents per kilogram. Well, I don't want kilograms. I want grams. So again, what you're going to have to do is another conversion. I'm just going to, I can't get back to the screen where, to erase. I'm just going to write it here again. King Hot Dog drank cold milk. See, meters is the unit of length in the metric system, but now we're talking about grams and kilograms. That's the unit of, but they use that as for weight. So instead of pounds, they use grams. All right, so anyways, it's 30 cents per kilogram. Well, I'm going to put the money on the top. And that's what we're going to be left with, okay? 30 cents per kilogram. I want grams. Per kilogram means 1 kilogram. Go to, okay, let me get rid of this because we're done with that one. We're over here. Go to kilograms, which is the K. We want it to be in grams. Where's grams? Grams is the unit. Again, instead of meters, we're talking grams because it's weight. So right in the middle is your grams. So if I'm on kilograms, I would go 1, 2, 3 to the right to get to grams. So if it was for 1 kilogram, I'll go over here. If it was for 1 kilogram, right, I would go 1, 2, 3 to the right, fill it in with zeros, and you're at 1,000 grams. Okay, so you're taking per kilogram, you're taking the kilogram, and you're converting it to grams. Now, if it already had it in grams, you wouldn't even do any of this, okay? You would just plug in the numbers. All right, next step, let's see if we have the units lined up right so they cancel out top, bottom. So cubic meters will cancel top, bottom. Grams will cancel top, bottom. And what's the unit that's left? It's the money, and that's exactly what we want. We want the cost for 250 bricks. So at this point, you're going to multiply straight across on the top, that 0.264 number. Okay, multiply that times that 1,920,000 times 30 cents. So everything on the top. I usually do it all in the calculator. I don't write it down yet. And on the bottom, we have 1 times 1 times 1,000. So really, you're just dividing by 1,000. And when you get your answer here, remember, this is money, and it says round to the nearest dollar. So you should have $152. So if you feel that you need one more practice watching a dimensional analysis problem, here's another one. So we have a snow cone that consists of a paper cone completely filled with shaved ice and topped with a hemisphere of shaved ice. So even though in the diagram you can only see the ice on the top, it says that it's filled inside as well. The diameter of both the cone and the hemisphere is 8.3 centimeters. The height is 10.2 centimeters. The density of the shaved ice is 0.697 grams per cubic centimeter. Now, so far we're fine because we have centimeters and the density is cubic centimeters. The cost per kilogram of ice is $3.83. Determine and state the cost of the ice needed to make 50 snow cones. Very similar to number one, we just have a cone and a hemisphere instead. First step, let's find the volume of, let's do the hemisphere. So remember, hemisphere is half of a sphere. So I'm going to take the sphere formula and just put 1/2 in front of it. So 1/2, 4/3 pi r cubed. Okay, now the radius we don't have right now. It said that the diameter was 8.3. I divide by 2 and I'm getting a radius of 4.15. So that's what I'm going to plug in for the r. Now this problem, I'm going to do it not in terms of pi. I'm just going to type in everything. Okay, so we're going to have a lot of long decimals to deal with in this question, unfortunately. All right, so type this whole thing into the calculator and you're going to get 149.693. Remember, you can't round because we're not done, so a lot of work to do. 0.6934866. Next, you want to do the cone because it says that the ice is filled in the cone as well. So cone is 1/3 pi r squared h. It's really 1/3 of a cylinder. All right, so we already found that the radius was 4.15. And the height of the cone is 10.2. Same thing, I'm going to type everything into the calculator. So when I do that, I get another long decimal, 183.9606.702. Next step, you want to actually add those two volumes together. So let me do that here. Still not rounding because we want the volume of the entire solid. Okay, so here's your volume. When you add those together, you get 333.6541569. So that's the hemisphere and the cone together. As I did in number one, I like to multiply by this 50 now because, like I said, sometimes you might forget about it. We're finding we really need the cost of 50 cones, which means the volume can be multiplied by 50 right now. Okay, so I'm going to take the volume of the hemisphere and the cone together and just multiply that by 50. And once we do that, we have 16,682.70784. And this is, what was this in centimeters? So this is going to be cubic centimeters. Okay. Now, at this point, let me move this up a little bit. Actually, I'm going to separate this out because we can do the dimensional analysis with it. All right, so we take this, we're going to put it over 1. Now remember, we need the cubic centimeters to cancel, so cubic centimeters has to go on the bottom. Okay, so let me scroll up a little bit. Here was the cubic centimeters. It was 0.697 grams, that will be on the top. And it says per cubic centimeter, so for every cubic centimeter, 1. Okay, so see how cubic centimeters will cancel top bottom. Now you need grams to cancel top bottom. Well, where does the grams come in? It says the cost per kilogram is $3.83. So 383 is for 1 kilogram. We don't want kilograms, we want grams. We did this before in the other problem, but I'll show you guys again. So we go King hot dog, drank cold milk. Remember with the units in the middle, which is grams here. The problem said 1 kilogram, but we want grams, and grams is the line. So I move the decimal 1, 2, 3 to the right. 3 to the right. Well, if it says 1 kilogram, 1, 2, 3 to the right would be 1,000 grams. So now we're in grams, which means the units will cancel top bottom for grams, top bottom for cubic centimeters, and then you will be left over with the money, the cost. So in the calculator, I'm taking that number, which was the volume. I'm multiplying it by 0.697 straight across. Then I'm multiplying by $3.83. On the bottom, it's 1 times 1 times 1,000. So really, I'm going to take whatever I got for that and divide by 1,000. You can show more work. I usually just put it all in the calculator. And it says determine and state the cost. It actually doesn't say how to round, but it doesn't say nearest dollar. So you don't want to round to $45. Money is rounded to the nearest cent. So $44.53.